What's up? What's up? What's up, everybody? How's it going? Happy Tuesday.
Hello.
We're
Great.
back. We're back. It's Teaching the Toolkit / Game Dev Academy Tuesday. That it doesn't. Teaching the Toolkit Tuesday kind of rolls off the tongue more, I think. But yeah, it's good to be back on the live. Good to see you guys. Good to see Jack. And today we got another special guest, Mr. Wonkee Kim, everybody. One of our favorite engineers at Spatial is here.
Thank you very much.
To talk about lighting and everything to do about lighting. So if you've been in any space in Spatial that like we've built, like Agora or some of these other spaces, or some of our recent games that have come out that have like, you just notice like the visual quality is at another level, or like the lighting is at another level, probably due to this guy here.
All wonky.
all wonky. He is
Wonky is the man.
Yes.
Thank you very much.
One of the most overlooked parts, I think, of a game, that and like sound, I think, are two of the most overlooked things. We'll actually be doing a stream about sound and music in a couple of weeks, which is going to be awesome. But I think lighting is definitely like when you see a space that has good lighting, like you immediately notice like if that lighting is taken away or vice versa. When there's a space that has really bad lighting and then the lighting's changed, it almost feels like night and day, I think. So Wonkee, really awesome to have you here. Thanks for spending the afternoon with us. Cool. And I'll let you like introduce yourself and tell the world who you are.
Yeah, thank you for having me. Yeah, I'm very pleased to have this one, and I'm very pleased to meet very creative our creators. Like, yeah, it's a specialist platform, right? So we are working with great creators to like make some great rooms and great environments. So I'm pleased to here. And I'm a technical artist, so I do kind of stuff of lighting and some visual this stuff like so technical artist. I'm kind of between art and technology, so with understanding of the rendering or render game engines. So I enjoy to make some graphics better and great. So that's me.
That's awesome.
Cool.
Yeah. Thanks for doing. Yeah, all the graphical stuff that you've done is just next level. I'm excited for people to see like kind of the stuff you've done, and then like get into I think the stuff that people are excited about. They ask us, right, Jack, all the time. Like one of the top questions we always get is like, how do I make my space like look better? How do I implement like different lighting techniques in Unity to make, especially now that we have the toolkit, right? Like I think before a year ago, getting a space lit well was really, really hard when you had to bake lights into a model, like especially like using Blender or things like that.
Super long, tedious process.
And now with Unity, like that's much easier, but there's almost so much you can do. There's almost too much you can do, right? Like that's so powerful. So like I know for years I've been coming to you being like, how do I make this actually look like halfway decent? And you've been like so helpful. And even when people come in like ask like me or Jack how to do that, oftentimes when we tell them, hey, like we'll get back to you, it's because we're going to you to ask you how to do stuff. So now we're right to the source.
Yeah, exactly. I think the hard part of the making lighting environment looking good is like if you are very good eye, if you have very good eye to make something really good, but still in Unity engine, you need some kind of some understanding about the real-time engine. So it's kind of some different things. And even you understand well about some rendering engines, but still you need some good eye to making looking good. So as each kind of some good combination will be needed, but I think that should be a kind of tricky part. So and we always have kind of some like while we are working with creators, and we always had many questions about the lighting and some environment look development, right? But it is pretty difficult to explain something just very shortly. So it was very I always wanted to share some. So I know some good tips, but it's very kind of some not very simple to deliver everything. So I think this time it's gonna be really, really awesome. So I was very excited to have this time. And
it's a complicated topic because it's like there's even like physics involved with lighting, and there's a whole lot. It's not just like turn on a light switch and like it instantly looks good. I don't want to speak for you. There's textures, right? There's all these different things that come into play with this kind of stuff. But let's just jump in. I would love to. And you like this is like you're like our first guest to actually come with slides, which is awesome. So I'm excited for people prepared. This guy knows what he's doing. So let's just jump in if you want to like bring that up.
Yep. Let me share my screen. So awesome.
Yeah, it's so good that we have this good chunk of time to dedicate to this.
Thank you very much.
Totally. If you want to make it full screen too, that'll be or I guess just like bigger.
Yep. All right. So maybe all right.
Able to present it.
Yep.
Yeah.
So I prepared this one, so it has like 45 pages. But I was trying to put everything I wanted to share from the before. So anyway, it's 45 page. But so I'm gonna talk about some lightings in Unity, especially for our Spatial Creator Toolkit environments. So my name is Wonkee, and I'm a technical artist at Spatial. So before I joined Spatial, I also created some VR environment. Like I also created some VR content or AR content. So this is the environment that I created for a project, and also there are a lot of different environments that I created, and I also implemented this kind of some interactions with your hand tracking, so lip motion. So I did pretty much different role by myself. So from the
are those renders? Those like pictures?
It's Unity. Yeah, they are screenshot in Unity. So maybe
that
you
looks
can
real.
See,
they really do look real. Yeah.
I thought it was a photograph.
Oh, thank you very much. Yeah, and maybe you will be able to see. You are able to see the Unity icons here. So this is Unity editor. So
that's the giveaway.
Cool. So, and before I created the VR AR, like 2011, there was no VR devices, right? So I used to make kind of some 3D animations or motion graphics for some installations or exhibitions. So or some this kind of some projection mapping animations. So my base is pretty much artist. So basically I'm an artist, but I really enjoyed learning something, like learning coding, because I wanted to make graphics interactive. So like using coding, you can make graphics interactive, and even with shaders, you can make graphics more interactive, or some making things in real time. So I really enjoyed learning it. So and when I started using Unity, it was very fun experience. So I created this kind of some film and using Unity. So it was very fun experience. Also, so to make even each animations, 3D animations in Unity, you need to control all the animations in real time, right? So put some using some scripts, C# scripts or shaders, you need to make animations, control all the animations in real time. So that was pretty good. This project was that I really enjoyed before. So so I was maybe I think I call myself technical artist. So technical artists are like someone who creates some stuff in rendering real-time rendering engine. So someone who understands real-time engine and rendering process with kind of some artistic eye. So that's me. That's me, and I'm doing those stuff. So so technical artists like so maybe basically I'm an artist. So if I want to make something looking very beautiful as an artist, but if you like, so you might need some kind of some good understanding about real-time engine, Like, do you know the best way, the easiest way to optimize the scene? That is kind of just doing nothing. So if you don't put shadows, just remove all the details, then it should be okay. But that's not what I wanted, right? So that's what we don't want. So because we are artists, so we make things look beautiful. So just so to making look good in some like mobile devices or some WebGL devices, so you will need some understanding about the technology to make things looking better, not doing just remove all the graphics features like this. So I think that's pretty important. So so that's what technical artists do. So
So it's all in like the details, right? It's like making those details pop in a scene, because you can just put assets in a scene, like the boats and the water, or just like a plane for the water, and like that's certain artistic style, I guess, but like it's like your specialty is really being able to like take those little things and kind of have great detail in like the little things in the scene, but still keep it in a state that's like, especially for like real-time rendering, it's like well optimized, so it still runs well on like mobile devices.
Right. Exactly. Yes, correct. And for example, like if you put shadows, if you want to put some real-time shadows, the problem will be it doubles the draw code. Like if you have 100 objects in your scene, then by adding the shadows, the draw code will be double, like 200, because you need to draw all the object for the shadow maps. So like if you optimize your scene, like make this scene draw code maybe like 10, then maybe adding shadows will not be a big problem. Also same for the planar reflection. So if you want to add some kind of planar reflection, but if your scene is not well optimized, then the adding planar reflection will impact a lot. But if you optimize well, then it should be okay. So that's kind of some enabling all the details, like optimizations is like optimization affects to the final result. So
optimization is one of the most important parts to determine the fidelity and the overall look and feel that you can get.
Exactly. Yes.
All that optimized.
Cool. And maybe we'll just skip this, but just all right. Maybe like if you make your own environment, then sometimes it's very hard to make everything in your scene. So, but you will be able to find many good assets on the store, so you can download them. But there might be some possible problems when you use asset store assets. Like one might be render pipeline. So some assets might be too old, which don't support the universal render pipeline. Then you will need to convert everything into fit to the universal render pipeline. That can happen. And also Spatial Create Toolkit, we don't allow bring a C# script into spatial scene because it's not possible. So so if there's any asset that use C# script that cannot be utilized in your scene. So maybe these are two problems. So maybe problem one, the render pipeline issue could be resolved very easily, like because Unity already provides this kind of some convert selected working materials to URP. So it will convert all the standard render pipeline materials into universal render pipeline materials. So, but problem might be some if there's if the asset has custom shaders that is fit to the standard render pipeline, then in that case you need to create the universal render pipeline shader. But that might be tricky part. But but I wanted to recommend to use or learn how to use shader graph because it's very easy. So this is designed for artists. So you can make very cool graphics or cool visual effects using shader graph. So, and there are a lot of many nice, great video tutorials on YouTube. So so I would recommend to learn the shader graph, and you can convert all the shaders, standard render pipeline shaders into universal render pipeline shaders. So
So shader graph works with URP pretty much.
It's for URP.
Okay.
And one question I had too, Wonkee, how would, when someone's looking at the asset store, like specifically in the asset store, how can they tell what, like, let's, like, if you go to like that water listing that you had before, or if you want to bring up the asset store, like where are they looking on a listing for an asset to tell like what would be compatible and what's not?
It should be there. So there should be some the asset, all assets maybe show the render pipeline compatibility. So if you check this, then maybe you'll be able to figure out which asset is fit to your project.
That, and also like the C# scripts, right? Is there a way to find like if it has or if it needs or requires like C# scripts?
Right. That's a good question. For now,
I think a lot of people go to the assets are like, oh, this looks really awesome, like it supports universal render pipeline, I want to use it, and then they buy it or download it, and then it requires, like, for some of the water ones, like have a C# script to like control the flow of the water or something, and then it's like, damn, I'm out of like luck because this has a script on it.
I would say like sorry to say that it's hard to figure out which asset uses the C# script or not. So but I guess even if the asset uses the C# script, it could be not very a very big problem, because most of stuff like water shader or this grass shader, most of things are just running by a shader. So and what C# script does is kind of some control, like if it's water, then it control kind of some wave strength or those things, like, so you can even control those things in the material property. And even if you remove the C# script, then it should work, because the shader will be running on the object. So so for example, for this grass shader that we used for Punch Hero, it had this kind of color-made renderer C# script, which maps the grass color to look natural on the terrain. So, but I just removed this script and created this visual scripting node to just apply what I needed to do is just apply this texture to the shader, so to the material. So just adding this kind of some visual scripting, I was able to fix that. So also I saw another case, a water shader. I forgot the creator name, but he was asking about using a water shader, but it broken in Spatial because the shader actually generated through the C# script. So in the case, the solution was, I suggested to compile a shader from the, like, for example, if there's a material, then you will kind of, so there is a kind of some, you're able to compile the current shader. So I suggested to compile, oh my god, I pressed this, no. So compile, and then Unity will generate the shader file. So maybe you will be able to use that shader directly to your material instead of using the C# script generated shader. So yeah, sorry, it's not very clear answer, but yeah, there's no very clear solution. But yeah, but still there's room to resolve the problem. So
okay, cool.
And yeah, cool. And I can say it won't happen much because maybe most of case it just shader stuff. So yeah,
Got it.
Cool. Yeah. Also, I put this performance checklist stuff. Maybe we can review this again. Maybe at the end of the talk because I added this here again. So yeah, let's review this later again. So, but the key things of the optimization is kind of some baking everything, like bake mesh or bake lightings into textures, or bake everything into textures or any cache memory, so you can reduce all the complex calculations. So yeah, so key things is baking stuffs, but question might be, so what to bake and how to bake. So yeah, so like if for the lighting, so we will have these kind of things like light maps and directional maps and shadow mask and light props, reflection prop, and skybox. So these are what we can bake everything into textures. So Unity won't do very complex calculations when rendering. So yeah, so to basically Unity uses the physical based rendering. Most of render engines, the recent render engines uses physically based rendering. So if the artist, yeah, you guys heard about this, right? So so there's a very nice detail articles here. So I added this link here, so maybe you can read them if you are interested in how it works or more want to get more details. Yep.
Yeah, and we'll share these links and maybe this deck to you, Wonkee, over on the Spatial Discord after the stream's over, if you're cool with that, so people can have the links to check it out.
Yeah. That'll be awesome. Cool. So yeah, basically just in PBR, just what you need to care about is there are some material properties, right? Like albedo, metallic, and smoothness, ambient occlusion, and normal. So with these material properties, it can visualize these different materials with these material properties, right? So only one these textures, this lens object has like it has many different material parts like metallic or some plastic. So these parts can be visible with one PBR shader with these different the textures that are storing these different material properties. So and also Unity is the standard shader also uses the PBR stuff, so it has albedo, metallic, and smoothness instead of the roughness. So yeah, but one feature I wanted to mention about the PBR rendering is like everything is shiny. So like if we think about this kind of some clothes or cardboard, it's kind of it's hardly think it will reflect something, right? It's not mirror, right? But actually it reflects. So the below images are taken with some special filter on a camera, and you can see some reflections are appearing on the surface. So even clothes or cardboard or some bricks even reflect the environment. So that's kind of some very, very important feature that I wanted to mention. So like for 3D graphics, yeah, you should know you know about the ambient color or diffuse or specular, right? These are pretty familiar concept of the 3D graphics in 3D graphics, right?
I've heard it. I'm definitely familiar with the phrase. I've actually never taken the time to like understand the difference, and like that visual is like super helpful. I've like always seen it, and I always guess and check with trying different shaders, but actually seeing that is super helpful.
Yeah, cool. Yeah, so these are kind of some lighting models that are used in shaders to visualize the real life, really. So even this picture, you can see some diffuse shading, and some in the shadow dark part, you can see some the ambient color, some brightness, and also there's a highlight that that is specular in our some legacy rendering models. So yeah, these stuffs are all kind of some the modeled lighting models from the reality. But in PBR, there are some more features on it. So basically, PBR is the same. It has kind of some ambient part and diffuse part and specular part, but the feature on it of it is like energy conservation, which means like specular doesn't add the brightness. Actually, it's like the brightness should be the same. So between the different roughness the surface. So it's kind of some very important feature of the PBR. And also it should be image-based lighting, which means it should reflect the environment. So if the environment changes, then the object color should be changed. So basically, because every object is shiny and every object reflects. So these kind of some very kind of some most common or most important features of the PBR. So if we talk more about the specular, so I would say specular is just same to the reflection. So specular is reflection because like specular on this part, it just kind of this highlights kind of some source of the light, which is commonly as a sun, right? So if there's a sun, then you'll be able to see this stuff as a specular. And also this part, this looks specular, but actually this is the reflections of the outside, the most brightness part of the environment. And also this one, so specular comes here, is here, but it's like kind of the main light source of the environment. So yeah, let's check this in the Unity. So basically the specular is the most brightness part of the environment, but actually Unity adds a specular on it. So let's check it again. So if I turn off the main light, there's no light in the scene, and you'll be able to see this specular, which is sun of the 360 image, our Skybox image, right? So for this metallic image, also specular here, but actually Unity add specular if you add light. So this is kind of I would say this is fake, but actually, yeah, this makes object look better. So I think that's why Unity adds it. But still, there's an option. You can disable this. Like if you go to the material and there's a specular highlight. So if you turn this off, then Unity won't draw the specular from the light source. So it's kind of your option. So you can if you like the specular of the main light, then you can use it or not. So and here I wanted to mention is the direction of the main light should match to the 360 image. Like your Skybox is like this, but if your light is like from the top, then the environment is starting to look awkward because the skybox, the sun is here, but actually your light is from the top, so this is weird. So I usually match the main light direction to the 360 image. So as you can see, I match it the specular to the sunlight, and so the direction is matched.
That's cool how you do that, where you line it up with the skybox.
Cool. Yeah. It's pretty cool.
The power of the sun in the palm of your hand.
Yeah. Right.
Would people want to have specular on or off? Like, does it impact performance at all, or is it just purely for looks?
Not much. So
okay.
Yeah, it just you don't need to just feel free to change it so it doesn't affect to the performance.
Nice.
Yeah. So I mentioned about 3 parts. So basically ambient and diffuse and specular. Specular, which is a reflection of the environment. So these 3 parts. So let's try make this scene black because it's not simple as we expected. Like if we disable all the light in the scene, it should be black, but it's not black, right? Because Unity has some ambient part and the specular part, reflection part in each scene setting. So even there's no light, but it's not black. And if you go to Windows and lighting, where is it? Rendering and lighting, then in the scene tab, environment tab, and there's an environment lighting here. So source is currently Skybox. So if you decrease this multiplier, you will be able to see the ambient is black. But still, there are some objects are not black because we missed the specular part, right? So we turned off all the diffuse and we turned off all the ambient, but still there are specular in the scene. So if we back to environment and you can see this environment reflections, and if I decrease this intensity multiplier to the 0, then now it's black, right? So it's everything is kind of these 3 parts: ambient, diffuse, and specular. So let's back to the normal and diffuse, ambient, specular, and so light affects the diffuse, and environmental lighting that we change it affects to ambient, and environmental reflection that it also change it affects to the specular, the reflections. And and now we need to bake these things as much as possible into texture or somewhere, right? So diffuse and ambient can be baked into light maps and light probes. So light maps and light probes stores the diffuse lighting and ambient lighting. And Unity also has reflection probes. So reflection probes stores the 360 image of the environment, right? So it will affect to the specular to the like kind of the reflective object. Basically every object. Yeah.
And one could just take one step back. Also, for those who may not know, what does it mean when you're baking your lights? Because I'm assuming it's different than baking some muffins in the oven. So what when you say like baking lights, like what is that like doing exactly? Like what is that when you say baking?
Yeah. So very good question. So light maps so light map is the texture that stores all the diffuse and ambient color into the textures. So textures contain all the lighting informations which is pre-calculated before and all the stored in the texture of the surfaces. And also reflection probes are also 360 image that store the kind of some environmental reflection, the 360 images of the environment. And also there is a light probes that stores the lighting information, like it's kind of some capturing all the lighting of the environment in this kind of some sphere. No, it's kind of point. So like it's so with 16 float values, we can approximately store the light information into this 16 float structure, so which we call light probe. So like with some numbers, you can see some different kind of some maps. So if you think about, I think these like I think this represent good. So like light can be from the top or some left or right or some different colors. So it can be approximately stored into some bunch of numbers. So yeah, actually light probe is 16 float values. 16. I might be wrong, but it's kind of 16 or 32 some float values stored into light probe, and each light probe contains the color of the environment. So
basically that really helps, like light probes in particular. There's also like the texture baking too, right? It's like light probes in particular, like so like to bring it down to earth per se. So when in like an avatar or character is moving through the scene, the light is reflecting, like the light color or like intensity or whatever is like reflecting off of the avatar or other objects, like realistically. But I guess that also gets to the question of the difference between like what is like real-time lighting and like baked lighting. Like what are the differences between those two, and like what does that mean in terms of performance? Like if I want to make sure that, you know, for me as a creator, the two things that are important for me is that my scene looks really, you know, looks as good as it can, but then also people can access that experience, you know, and there's no matter what device they're using.
Right.
So I guess, what are the differences between like real time and baked lighting, and like when should I use one versus the other?
Yeah, very good point. So so there are some different two types of objects. Like there are some static objects that don't move, and there are some dynamic objects that can move in the scene, right? So we can bake light into textures, but only in case it's static object. So like if we bake shadows like this on the surface, then we cannot move this object anymore, because if we move this, then shadow should move along together, right? So light map is more for some static object, like some environment object, and light probes is more for some dynamic object that is like moving around in your environment. So yeah, that's a little bit different. So light probe is kind of some approximate light, so it doesn't store very detailed information. So light map will be still the best option to bake all the details of the lighting of the environment. But for the dynamic object, there's no way to bake things into textures. So in that case, we can use light probes. So yeah, to have the dynamic light. Maybe maybe I can explain that too later, maybe in the how to bake stuff. So yeah, but that's a very good point to mention at this point. So
sure,
yeah, cool. Sorry. Right. So now we know what to bake, right? And I wanted to mention about the how to bake those things. So sorry.
I think cooking with Wonkee, how to bake.
Yeah, thanks. Yeah, yeah, bake, cook. Right. All right. So like this kind of my process, but I would recommend of this kind of process because it helps a lot to like enhance your like fast iterations and having getting good lighting step by step. So yeah, let's talk about the first one first. So so reference. So I really want to recommend to find some good image references before you start your lighting, because it's like there are a lot of nice but great light examples in everywhere in the internet, so you can find many good images, and it can inspire you, and also it can be kind of guide when you decide some kind of some ambient color or some main light color or main light intensity, everything. So if you have some good lighting example of your project, then it will be kind of a guide of your lighting. So it helps a lot. So it's not copyright. It's just yeah, refer the
Inspiration.
image. Yeah, inspiration. Yeah. So
Renault kind of had the same technique when he was sharing his stuff last week.
Yeah. Inspiration. Yeah, it's very important. So yeah. And then right, maybe I can start with this example. So yeah, let's do some progress together. So maybe before I start, I like this one because it has very good color, and it's very soft and very rich in midtone. I like midtone because it doesn't have very big contrast, but very soft, and yeah, I like rich in midtones. So I will like kind of try to achieve this kind of lighting look and feel. So, and before I start, I really recommend to have a lowest lighting setting. It's kind of number 2 here, because it will enable you do some more experimental lightings when you bake lighting, when you like determine some light settings. So let's start from the beginning. So I will create new lighting setting, and this is kind of some Unity's default. And yeah, I will use the shadow mask, but I will lower all the options as low as possible, because it will very enhance the speed of the bake lightings, and I can get very quick feedback. So yeah, I really recommend to use GPU, because yeah, it's much faster than the CPU one. And I will disable this progressive update stuff, and I will put 1 to these sample count, and these are lowest, and I'll keep these stuff, and filtering, let's keep order. And the lighting resolution will affect a lot to the speed of the light map baking. So I put just 4, which is very low number, but yeah, but we can still have get the the look of the lighting. So and I usually use 248 texture, which is pretty good balance between, yeah, so it doesn't yeah, it's pretty good balance. And for the lightweight compression, so Unity will choose one of the compression. Like for mobiles, it should be, the high should be ASTC 4x4, I guess, and low might be ASTC 8x8. But it's like, it depends on the Unity setting. But as we added so we put our kind of some utility, some which changes the texture settings. automatically, so it doesn't matter. So this setting won't be ignored by the utility. So I would recommend to use none here, and our utility will convert the texture compression. So just have it none to save the compression time. Yep. And I will disable ambient occlusion for now. So yeah, and the directional directional mode is for some normal map on the surface, but yeah, it increases the light map textures a lot. So I usually don't use it. So I recommend to just use non-direct directional lighting. And I'll have this light map parameter very low, and then with this setting, if I press generate light, and it can be finished very quickly. Like yeah, it doesn't take. It takes only a few seconds, right? So so you can change your value, and you can see the result very quickly. So this kind of some fast iteration is very important. So yeah, so I would recommend to keep the lowest setting. So before start your lighting. And I usually set the ambient first. So which means I think I would say the having right skybox is the most important of the lighting, because it's much more important than having a good light in the scene, because it determines kind of everything of the scene. So like for example, if I change this skybox to this one, and the look just changes just instantly, very differently, right? So selecting the right skybox for your reference image or for your target image will be the most important stuff. So yeah,
really changes the vibe of the whole space.
Yes, true. Yeah. And the reason why everything's white here and too bright, so I usually turn off all the lightings in the, so when I start lighting, I turn off every lighting and leave only skybox and see the ambient. So this is without any light in the scene, and as you can see, everything is already pretty bright, right? So I saw many room have kind of some very right. I put this slide at the end of this slideshow, and like yes, I saw many rooms. So backlight is not very clear in the environment. Like sometimes ambient is too bright, or sometimes ambient is too dark in the environment. So this can happen because if you don't handle the ambient well. So that's why I recommend you to turn off all the light in the scene, and then you can clearly find out the skybox, how your skybox affects to your scene. So, and then now there's a problem, right? So the current skybox is too bright, and it makes everything too bright. And the reason why the sky is just white is because it's a high dynamic range image, which means like if we say 0 is black and 1 is white, but in reality, even it's white, but it can be much brighter than white, right? Like sunlight is much brighter than the white paper in the office, right? So light brightness can be more than white color. So that's why high HDR images is very important, and the concept of the HDR image is very important. So I change the brightness exposure of this skybox, and you will be able to see all the details here from here. So which means, yeah, this skybox image contains all the details in it, but just our render engine just render everything just white because it's more than one value. So and also because it's too bright, it affects to the surface. So the every object already have a very high contrast with the, so it's very hard to say it's ambient light, right? So what I usually do is make things in just single image. Like, so this image is JPEG image that I converted HDR image to just a single image, which has only one range, only range of from 0 to 1. So by using this image, you can see the lighting, the contrast is not high, and everything starting look like ambient, right? So yeah. So yeah, maybe
So
maybe
one of the key parts there was converting the HDR skybox to a JPEG non-HDRI skybox. Okay, and it makes it a lot softer.
Right. That's yeah, correct. So to do that, what I usually do is open the HDR image in Photoshop, and there's an option to adjust it, like it's a tone mapping somewhere, adjustment. Yeah, HDR toning. So you can adjust the HDR image in a very good skybox. Or what I used to do is just change the mode from 32 bits to 8 bits. And then, and as our target image is kind of this, which is kind of some rich in mid-tone, so I don't want this big contrast between the brightest part and dark part. So what I did is make a high gamma and exposure and reduce the highlight and enhance the saturation. So like I put everything in mid-tone, so it doesn't have too much high the brightness and too much darkness in the image. So yeah, that's what I did for this skybox image, and I was able to get this ambient light. So yeah, sure, thanks. Yeah, so yeah, selecting a good skybox and have a good adjustment on the HDR image, and have a good ambient lighting in the scene. And one problem here is inside the structure is too dark, right? This is not like this, right? So I wanted to make this inside some brighter, like bright, but there's some options to like enhance the brightness of the bounced light. So the first one might be in the lighting settings. There's an indirect intensity. So if you increase this, and then the bounce lighting gets stronger and it gets brighter, right? But problem is because it also bounced outside, so everything is too bright now. So it's not good option. So, or another option is like when you have main light like this, and every light has this indirect multiplier, which means we can also increase this multiplier of the light, so it will bounce more, but still it's dark inside and bright outside. So what I usually do for this case is having a direction light with no shadows setting, which means it right. So it doesn't draw shadows, and it will affect to the inside of the structure. So just let's bake it first. Yeah, as you can see, the inside is getting brighter, and outside it doesn't affect much. And also I added another and bake, and here it's getting bright, right?
Yeah.
So this is what I wanted to have, like kind of some not much contrast and have kind of some mid-tone ambient. Yeah, so everything looks starting to flat, right?
Yeah, it's starting to come together. There was a question, some questions in the chat I want to get to. Rezo asked a question. They have a baked light map that's 300 megabytes. Unity is compressing it to 30 megabytes. I think because of, I'm just reading off the question here. I think because of the starter content, I got my light map compression set to none in light mapping settings. So I got this. So and then they continue. I got the scene with 30 megabyte light maps and textures of 70 megabytes, which is 100 megabytes in total. The limit for spatial is 200 megabytes. So how can they control the strength of the compressions in Unity, the light map compressions?
Yeah. So yeah, the compression setting is pretty important, right? So, but as you installed our Creator Toolkit, it should be like it should change the compression setting automatically. So if you don't have, so like for example, if I where's my, so for example of my current scene, this light map texture in the, so if you go to the baked light map tab, and you can see the light maps in your scene, and then it will guide you where's your light maps in your project. So if you select your light map texture, then in the inspector, you can change the compression settings per each platform, like Android, which is Android Mobile and Quest, and iOS and WebGL. So our utility, so this utility should be included in our Creator Toolkit. So it will automatically convert your light map textures to Crunch DXT5, which is pretty compressed, very aggressively. It compress textures very aggressively, so it will reduce a lot of texture size. So maybe, but if you don't like this, you can change this setting anytime. So like this. So if I compare the size, Crunch DXT5 is only 30 gigabyte. Sorry, kilobyte. But RGBA 30-bit, which is non-compressed, is more than 10 times bigger than the original. So yeah, I would recommend to use Crunch DXT5, which is kind of default when you bake light maps. But sometimes if you don't like, in case it could produce a lot of some visual artifacts, like especially for some what's the name, the bending issue. So it can cause a bending issue. So in that case, you can change this to compressed DXT5. Yeah, then it doubles the size, but it will look much better on the surface. So yeah, does it make sense?
Yeah, that's pretty good to know.
Cool. Yeah. Let me cover about the compression setting later again, because I also added this here. So cool. So now we have ambient light, right? So we have both skybox and ambient lighting settings. So everything look flat and not very contrast is pretty low. Now if I can add my main light here, and I can see the main light affect the scene and bake. So, and then you can start from the ambient lighting, and then you can add main light and more additional lights based on this. So I think this process makes your work much easier. And also, as we have the lowest setting, as you can see, the changing and baking takes only kind of a couple of seconds, so which is pretty over. Like, so you can experiment much. Like if you want to try this yellowish strong light, you can see how it look like. And if you want to change your ambient light more bluish, then you can experiment more. Because of this lowest setting. So I will recommend to this one. So
nice.
Right. Cool.
Yeah, this feels like a very different, just with adding those lights and the ambient colors and stuff like that. It feels like a very different scene than it did when you started just a few minutes ago.
Right. It changed a lot. So cool. All right.
Awesome.
Cool.
And I don't know if you're going to get into it, and I'll let you. I know you have more like slides and topics and stuff like that too. But I know another question was around volumes and global volumes and how that plays into it as well. But I'll let you like what volumes are and how and if people should use them for like additional like lighting effects.
Right.
But I'll let you. You can keep going through your list, and then because there's a lot of good stuff here.
Right. Right. So we mentioned about the HDR images, right? So out like post processing for me, it's more like controlling the HDR lighting into, like, for example, like currently the light intensity is 1, right? So it looks soft. But if I want to strong, so if like if I want to have a bloom, but it could make everything pretty blurry, right? So we don't want this, right? So in that case, we can increase our threshold. So the bloom will only blur the brightest point. So and it's kind of combination. So like if you want to increase your main light intensity, like this, and then you can add blooms on your surface. So your main surface will have the more bloom on your bright part. But problem now is because it's too bright, it's more than 1 brightness, so everything looks too white. This is definitely very ugly, right? But in the post-processing, there's a tone mapping here, which does, like if I apply neutral, and everything look like starting, it kind of it remaps, it adjusts the HDR of the screen into some kind of mid values. So
are there what's it called, performance effects from using like some of these features?
All the post-processing effects in the URP, Universal Render Pipeline, these are all super light. So you can use everything. So, but except depth of field. This one is
that's my favorite one. So of course that would be the
yeah. But this one definitely it's a little bit heavy than others. And next is bloom, but bloom is pretty looking good, right? So
yeah.
So yeah, it should be okay. Just using bloom should be okay, but the depth of field might be. But it also, yeah, everything is very well optimized. So you need to actually you don't need to care about the performance when you use post processing. So it's okay.
Yeah, I know. I always love, as I like to do photography on the side, and getting that depth of field like blur is always really, really cool. I know we have that effect. You implemented it on the in the recent stage environments that we put out.
Right.
So like the island stage, I'm blanking on the Haven stage.
Haven,
Haven stage, and there too. That and motion blur, I like to use a little bit too, especially for like games and stuff, because it adds like kind of that like cool effect. But I know like you don't want to get too heavy with either of those. Just like a Stellar Extinction over on YouTube just summed it up really nicely. Depth of field equals bad, so that's all you need to know when it comes to values.
Remember that.
Our stage had it right. Sorry for that. But it should be okay. But just it was kind of some stage environment, kind of some the environments that we provide, right? So it should be fit to every devices. So it's kind of pretty. It should be okay to use it for your for environments. Right. So sorry, what was the question about the volume? So it's like and global volume and local volume, right? Or
it said
the global volume, the global volume features. So I mean, the Stellar Extension's question they asked about 20 minutes ago was if we'll be covering it, because they've been using it as a way around not having to access post-processing settings in the toolkit. But I think you're really covering it there. And for those who don't, I think also just for those who don't know, volume as a feature within Unity is really, really powerful. It helps, like you're seeing with like the tone mapping and bloom and stuff that kind of like elevate. I think it really elevates like the visual quality of a scene to when used correctly, right? Like there's a ton of those post-processing features that are available there, but it really kind of takes, it's almost like gives you that feel of like a 3D Photoshop to a degree that like it takes like the scene and just like gives it that like extra sparkle, which is really, really nice. But I think treading lightly, like don't throw the kitchen sink of volume features at everything, but like try out different things and see how that could like make the experience like that much nicer for like the bloom. Like you're seeing that obviously you can use too much bloom and you get like kind of the J.J. Abrams effect of like just like the bloom everywhere kind of thing. So like use it, but also don't like annoy people with like too much of like especially if you have like shiny objects in your space. There was a follow-up question. Are there any other than depth of field, are there any other volume settings that should be avoided for performance reasons?
Volume might be the second, the heaviest one, but it's okay. So everything's very. So all of these are calculated in very lightly because like. So like for example, if you have multiple effects, what Unity does is like look texture. So there's kind of lookup texture, which means like it's kind of one of the post-processing technique. It replaces the entire screen color into lookup texture. Like for example, like so lookup texture looks like this. So it contains the 3232 red channel and white green channel and the blue channel. So if we like kind of adjust this image, then like if we pick the same color, same pixel of this image, like if we adjust this lookup texture image, then the result will be the same in the final screen. So it's kind of technique of the lookup texture. So what Unity does is every post-processing effect, like all the color adjustments, not chromatic aberration, like all of these color adjustments, Unity applies these color the color adjustments onto the lookup texture first, and then at the very last, Unity replace the screen color using that lookup texture image, which means it's very, very light. So yeah, you can even multiple very different all the other some kind of color adjustment. Yeah, just the images effect, post processing effect. It doesn't matter. So yeah, it's very light. So I think yeah, you don't need to care about the performance when you use post processing.
Okay, yeah. Cool.
Good to know.
Good, yeah. And like volume, so there's two different type of volume, right? So one is global and one is local. So like what local post-processing does is like if I add one more maybe I make it export here and expand this area. So which means it will affect to this post-processing will be applied when you inside of this area. So you can use this for Universal Render Pipeline doesn't support the auto exposure, which is pretty important for high quality the image effect, but which means what auto exposure does is if you look at the brightness part and the screen should be like our eyes. If we see the bright part, our eyes adjust the brightness. How can I say this? Sorry. Anyway, so if we get into the dark side and we widen our eye to make it look better, right? So it's kind of auto exposure. So in most game engines uses this. So if you get inside of the dark space, it should be the brightness of the screen should be adjusted, but Unity doesn't support it because to calculate the brightness of the screen, Unity might need to use the shader compute shader, but our WebGL doesn't support compute shader stuff. So in that case, you can use this kind of volume if I increase this blend distance. So like if you are getting into the dark room, then you can adjust the brightness of the space, so you can see different look inside of the room. So you can use your local volume to adjust the look.
That's awesome. Yeah, cool. So you can have almost like very different like visual effects when you go into different parts of the space. You can go from bright and colorful, and then you can go into one room and it's black and white, effectively, or something like that, which is pretty cool.
Right. Yes. You can use that. Yeah. Also, like you can use like if you go to under the water, then you can use the volume to make it.
Yeah, that's a great. I've seen some spaces on Spatial that do that really, really well. Yes. If you get that level of detail, you go below that. You put that local volume just below like a box collider below the surface. Yeah. So when you go down, you get like those like sort of like I forget which post processing they've used, but like different effects like maybe motion blur and stuff like that to make it feel like you're under the water, and it's really effective.
Yeah, right.
Yeah, it stands out. It's very cool when you see that.
Cool. All right. Let me. Do we have more time? We have
as much time as you like. As much time as you have.
Cool. Yeah. All right. So we set the ambient color and we determine the main light color and additional colors, but still we are able to see some problems inside here because here the object this object the supposed to be dark, right? But it reflects the sky, which is very awkward, right? So in the case, you can bake your environment, your specular into texture. So like we'll enable all the reflection probes here. And if I bake it again, and now you see, the reflection is much natural, right? So
yeah, it's actually reflecting what it's actually around.
Yeah. So I saw this case a lot because it's like without these reflection probe changes, like sometimes in this case it doesn't change much. But all right, maybe I can add this point light here and then okay. So objects are supposed to be blue here, but actually it's not blue, right? So, which means if your avatar walks into this bluish room, but your avatar can be too dark or can be reddish or random color in your space. I saw many, this case many times. So, which means, you need to care about the reflection as well to make it look correct inside of or you're in your where you are. So so by baking reflection probes and the object inside of this reflection probe, we'll use that reflection probe for each specular. So as you can see, the area is like this. Inside of the room. And also your random object like this will look better with this reflection probe. And maybe I wanted to show you this, like, and for example, if you move outside of this room, and as you can see, this reflection, the specular changes instantly, right? But it shouldn't happen in spatial because we already enabled the reflection blend setting. I just wanted to just mention. So in spatial, we enable this probe blending in the setting. So if you bake reflection probes in your scene, then it will blend your specular when you move inside or outside of the specific areas. So
so it's like a gradual transition versus like a hard transition.
Yes, correct.
Which is nice.
Yeah. Cool. Thanks, Jake. And another problem here is this one is still not blue, still purple, right? So it's because every lighting is baked into textures for the static object, but this one is actually not static object. So this is dynamic object. So in this case, you can use light probes. So, and if I enable this one and bake again, and you can see it's more natural inside of this room because these light probes, as you can see, it's, as I mentioned before, it's kind of some approximate of the current light from this point, each point. So this point, there's a blue point here and blue point here. So it's kind of approximate value. And what Unity does when render each object, it kind of forms this kind of tetrahedron shape, using some light probes around each object. So if our light probe is like this, and then you need to pick some of the light probes close to the object, and then using them, blend those light probe images into object when it renders the ambient tone. So definitely in this case, ambient light probes affect to the ambient. And as you can see, if I move out, it gets changed the ambient color because light probe is changed outside.
That's
so
awesome.
Cool, yeah. So light probe setting and reflection probe setting is very important than you think. So I really and this is kind of some sometimes it's kind of some annoying stuff, right? The placing or the reflection probes and all the light probes, but it's annoying, but it's very necessary because with dynamic object or with the avatars in the space, it changes a lot. So yeah, I saw many cases the avatars look dark or some random color appear.
Yeah, things are just like I think it's going from like a flat space that's like very almost like PlayStation 1 looking to like adding these light probes and stuff like that can bring it up to, I don't know, PS3, PS4, depending, it could just it brings it up a few generations, and I think it's really important. And there's great I know where there's so much to this. Like if like you were going through like a detailed like how to add the light probes and all like getting into the details, obviously we could spend like hours. I'm not ending us now. I'm just kind of saying like you can spend a really long time on it. Unity has like the Unity Learn platform, and learn.unity.com has great tutorials, like detailed, like step by step, like how to add light probes and going into all the features and setting all that up. And stuff like that. So I highly recommend going to learn.unity.com and checking out their like light probe and lighting tutorials. It's like super interesting and super helpful.
Yeah, right. Yeah, there are a lot of great tutorials. So yeah, it's very super important.
Somebody asked in the chat, Stellar Extinction said, are the volume settings taken into account when baking light maps?
No, it doesn't affect to, so it's kind of post-processing. So even reflection probes, when you bake the reflection probes, post-processing doesn't affect to it. So
nice.
Just post-processing happens just at the very last stage when you render the screen. So
I'm like excited to get into Unity like next time I get in, because I'm gonna know so much more about like these, just all the, first of all, what all these terms mean, and like knowing what the aspects of like the lighting they change and being able to play with them. This is cool.
Right. Yeah. It should, with these settings, it should be changed a lot. So cool.
Nice.
Yep. And what else do we have? So we already mentioned this, but just like, so having a strong intensity main light could work. Sometimes it can be achieve some different looking, especially when you use this with the post processing with bloom. So like bloom effect, you can see more than like more like fantasy look environment. So, but please note that the tone mapping is pretty important when you use bloom, because it's kind of combination of the brightness of the screen. So if the threshold is less than 1, then everything will look blurry. So if you have a higher threshold, then you will need to have a strong main light. A strong main light results to this exposed white surface. So in the case, you can adjust that with the tone mapping. So it's kind of some combination between light and post-processing.
So you ideally want to have both of those on for the best
Yeah.
look?
Yeah. One problem might be in VR Quest, we don't support post-processing. So Quest, it will look like this. That's the problem. So I think,
Okay.
yeah. So
And the reason for that is kind of limitations of the hardware, not so much like on us, but more on like how strong the hardware is.
Yeah, performance. Yeah, because
Performance.
VR devices has a high resolution on each screen, right? So post processing is affected by the number of the pixel you're drawing. So the more pixels there are, then it will impact a lot. So, so just by turning on. So, and also you need to turn on the HDR mode in the setting. So because without HDR mode, everything is just clamped into one brightness. It's not high dynamic range anymore. So it will look flat. So HDR is pretty important. So but just enabling HDR with one of the just processing drops the frame rate under the 40 on Quest. So
on Quest, but on web and mobile, it should be okay.
It should be okay. It's okay. Yeah, just Quest. Yeah.
Yeah.
Okay.
So yeah, I thought it's not. Yeah, we cannot. Yeah, make this work. So
yeah. And where was that HDR setting? How did you get to that again?
Basically, our creators cannot change this because the setting is in our creator toolkit.
Oh, okay,
So,
got it. Okay, so it's not something that we or creator need to turn on then. Okay.
Yeah, it's always turned on. Yeah.
Nice.
And for example, so brightness. So like this look like kind of some paper on the helmet, right? This is not the original. Yeah, we want it, right? So in this case, also you can have more than higher bright on this to make it more glowing stuff.
Ah, that's cool.
That's cool.
And is that all within just that object itself?
So this is kind of the emission of the object.
Okay.
Yeah, so it has its texture like this.
Yeah.
So what I did is, so Unity multiplies texture with this color value. But as you can see, this value is HDR color. So if you increase the intensity of this one, then it will be the brightness will be higher than one, just white. So you'll be able to see more glowing look, in your project. So
that's cool.
That's cool.
Yeah. So like if you want to have emission, then just everything is just balance between the light intensity, the pixel, the brightness of the pixel, and post processing.
Gotcha. Okay.
Yeah. Cool. And one thing I missed is if sometimes you like if you add additional lights in your scene, I would recommend to bake them, because like let me bake this without this one, and it takes more time because it bakes the reflection proofs and light proofs. Anyway, so if I use this just additional light in it, I think I need to change this mode to baked indirect. Yeah, right. Sorry. Yeah, this should be real time. Okay, sorry. Right.
That's all right.
Cool. So for the additional light, there are some limit count for the additional light. So if you have these additional light, real-time light in your scene, like 8 or 10 of the additional lights in your scene, sometimes you can see some flickering. Like sometimes some lights turn on and off in your scene. It's because you need to limit each additional light count. Maybe it's 4 or 8 something. So if one object gets more than 4 lights or more than 8 lights in the scene, it will not turn off. It calculates only the limited count of lights on the object. So yeah, it will flick. Yeah, and also for the additional light, currently we are using vertex light. So in these settings here, there's additional lights and per vertex and per pixel, right? So in spatial toolkit setting, we are using per vertex lighting, which means the light is calculated per pixel. So in this case, the spheres have so many vertices here, so it looks okay here. But problem, when you see here, it looks very weird because it's bright here and dark here. And also there's no kind of some radial lighting on the ceiling. You lose every detail here. So yeah, this results some very awkward lighting, especially when you have less vertices on your surface. So yeah, I would recommend to bake light as much as possible with the light prop settings. So yeah, it'll be look okay with it.
Okay.
Yeah. Right. What I'm missing?
We have another question. Oh, go ahead, Jake.
I was going to ask. I think you kind of touched on it there. Was there? What do you need to do? I see sometimes it's going back and forth there, but sometimes, like a light source might have, like say a directional light might have, a shadow affected, like on an interior room. Like, is there situations where that might happen, where like a light source might not respect like the structure per se, and like how to get around that, or will like by default and all the times Unity, like say like there's a light from the outside, but it looks like it's like casting a shadow or like lighting up the inside of a space. Is there a certain mode you have to be in to ensure that doesn't happen, or is that kind of happen by default?
Yeah, what I did is just set the shadows type, no shadows. So it will just pass through all the structure, and it's kind of some ambient light, but it has just the direction.
Right.
Yeah.
Okay.
Yeah.
Got it.
So you can use directional light as an ambient light by turning off the shadows.
Cool.
Okay.
Cool.
In the chat, Sean Young asks, any tips? Yeah, any tips for baking reflection probes, light probes when you have a large area of water in your scene? For example, sometimes the speculars on my terrain will reflect blue, and I have a night skybox.
Yeah. So yeah, you can also see the weird specular on my water, right? So as I mentioned, you can just disable the highlight specular by turning off in the material setting. So you can ignore that. Also, there's a reflection probe. So this should affect to this water. Like for example, if I create this plane and have the same material, and because we have this reflection probe, so reflection look weird, or and it affected to the another reflection probe. So for the water surface, what I usually do is I disable the other reflection probes in the render setting. But here's kind of some hacky part, because in the universal render pipeline they remove, so there is a kind of some light probe option here. So I turned off this, but there's no option for the reflection probe. So if you have reflection probe in your scene, then it will affect to your water, so it won't look like this Skybox only. So in the case, what I usually do is back to the standard random pipeline. I asked Unity Korea, Unity Technologies to fix this, but I don't know, maybe they are busy. So anyway, yeah, here I changed this to the standard random pipeline, and it's purple because it's broken because the shaders are a Unity random pipeline thing, right? But I changed this setting to the random pipeline setting, and then you can see this reflection probe setting here. So I turned off here. So it should be this one might be the default setting. So like I can show the default. So if I back to the original, then you can see these very weird reflections on the water surface, right? So I don't want this. So I don't want to any reflection probes affect to the water surface. So this can be an option. This is very weird, I know, but yeah, there's no way to this. So just back to the default random pipeline and change the reflection probe setting off. Then it will use the scene reflection source of the scene. And if I back to URP, and yeah, you can see it reflects the ocean. So any other some weird stuff will appear on your water. So yeah.
Yeah, and so you're able to prevent the colors from the water reflecting into anything in the scene as well.
Yeah.
Okay.
Yeah.
Nice. Oh, that's cool to know. You answered that so easily. Nice.
Yeah. Nice. Yeah. I did the same for this Agora surface, and also yeah, I also did for this water. So it uses the reflection probe, maybe near the scene. Yeah, this one. It uses this one, and there's another water surface. So this water uses this reflection source.
Okay.
Yeah, but this reflection uses the different one, the main one in the scene. So yeah, everyone uses the different reflection source.
Okay.
Let's throw back to Spatial Park.
Yeah, I want it back.
Yeah, we should redo it in with the toolkit. Had some toolkit features to it because it's a beautiful space.
Yeah, it really is a great park.
Mm-hmm. Yeah, they look great. Cool. So yeah, once I decide all the light settings, then another part. So and you need to like so far I use the lowest settings. So light map is only 256 resolution texture. So I need to bake the final one. But before you bake, you need to find very good resolution here. But like you need to find a good number here. Like if I change this 19, then if I and bake, this is also pretty important because if the number is bad, then you will like waste a lot of textures. Like for example, it uses 2K texture, but as you can see, like kind of some 80% of the texture is wasted. We are not using them because of the number is not good. So yeah, you need to find a good number here. But when you find, maybe with these enabled settings, every time you bake Lightmap, it will bake all the reflection probes, light probes, everything. So it's kind of some waste of time, right? So what I recommend is just turning off any other light settings when you find a good number of the resolution here. So for example, if I bake it again, and it finishes pretty quick, right? But if I enable this, it takes more. So the time will be increased a lot if the complex, the more your scene is complex. So actually it took about a double time. So when you find a good number, and I recommend to turning off all the lighting settings in your scene. And then with 17, as you can see, it uses 124, but everything pretty fit, but still not good. So I will try 18.
Do you normally always just try those random numbers and then see which one ends up working?
Yeah. I usually try just one by one. Have to find the very.
What's the highest number you ever had to use? Is it like always under a certain number, or
I'm not sure.
does it ever like take you a long time to find the number?
It takes 27. It for the Agora I use 27, so it uses all the textures very nicely, not much waste of the So
nice.
It depends on but usually kind of more than 20 is pretty much enough, but it depends on the situation. So
okay.
Cool. So with the number 18, it's not perfect, but it's the best now. So because if I use 19, it uses 2K texture and with 80% of the texture. And if I use the 17, so it was not enough. So 18 is kind of best, not perfect, but best. So once I find a good number, and then I turn on every light, and then increase numbers and then turning on the ambient occlusion and bake to get the light maps.
Yeah, that's funny. The button isn't bake light; it's generate lighting. So that might be like for people who haven't done it before, look for generate lighting, even though we're calling it baking.
Yeah, I think because it bakes the reflection probes and light probes, everything. So generate. I don't know. It's not baked.
That's awesome. Yeah.
Cool. Yep. Right. So pretty much.
What other tools do you have for us, Wonkee? Anything?
I'm trying to stick to Unity's default things. Like there are some another light map solutions like what's the name? The Bakery, the GPU light mapper. But I don't like the third party plugins. Sometimes they perform awesome, but it's like I like the keep things light. I like that. So
keep it simple, simple and light.
Keep it simple. Yes, great. And also, I believe there's always a way to making things look good with the just basic tools. So I'm just trying to stick to the basics. So
that's awesome. This has been not only our longest, but like one of our most I think informative and interesting and important. I think ultimately like sessions that we've done. So this has been
a part 2 is imminent. I think, right? Part 2 is gonna.
We could do a whole semester just on proper lighting in Unity. So 100%. But did you have more slides and stuff you want to go through? I want to make sure we cover.
Maybe I might need maybe kind of 10
if you have the time. If you have the time.
Cool. So maybe we had a lot of complaints about the light map tech, the result, right? Because we forcefully changed the format to Crunch DXT, which is very result awful. But as you can see, we already have very bad the texture bending here. So because that's because we recommend to use this format as much as possible. But if you want to better quality, then just you can change it whenever you want. So it's like currently the size is 230 kilobyte.
Those are some big textures that we're talking about.
Yeah. Yeah, so if you don't like the Crunch DXT, then you can just whenever you want, just you can use the compressed DXT5, then it will look much better, much better. But also it will like kind of some the file size, it's kind of some tripled, so it's kind of some deal between the better quality, all the details, and or some smoothness of the experience of the game, so or your space. So yeah, it just you're yeah. But currently our the default will be Crunch DXT. So yeah, it will cause this ugly band. But
Yeah, and to clarify, also, so like it was in a recent update, like a couple of weeks ago. Like you had mentioned, some people were noticing like some of their textures started looking weird, and that was so one of the things that like you've been working on, and a lot of our team's been working on, is improving like the load times and like the stability of the platform. And a lot, like oftentimes what causes like spaces to crash or people can't get into spaces is because spaces are like really, really heavy, especially like texture sizes, and like tend to be like the major culprit of like, which is not something, you often, unless you're a hyper experienced game developer, like not something you always think about when you're publishing a space, that the textures are like well optimized. Like it might be like a relatively small environment, but the textures could be super heavy, which causes spaces to like stutter or people not to get into them. Or if it's, if you're on your mobile phone, would tend to be lower powered generally, like people might crash, the app might crash and stuff like that. So you had implemented basically this like auto compression for textures. So when people publish their spaces, like we're automatically applying that texture setting that you talked about, this Crunch DXT5 setting. So some people had already compressed their textures, that had inadvertently compressed them further. So some people who were already doing a good job of compressing their textures saw them compress further. So if you had seen that, no, that's why that was happening, and this is how you can basically revert that. But it was done in an effort to quickly basically improve performance on the platform, because there's oftentimes spaces that are very, very heavy that are causing that. Causing that to happen. So for people who experience that, we definitely apologize that they experience that, but it's being done to improve stability and performance like across the board. So this is helpful to see like how to basically alleviate that if you saw your textures were too compressed beyond what you expected.
Yeah. Oh, thank you. Yeah, thank you for the The utility, basically, if you made your compression setting before you already made each platform compression setting, then it won't change anything. So it changed the setting only when you don't have the specific setting in your asset. And I assume that it's like it's kind of some it can be compressed more better if you if you didn't pay attention on it. So it changed the compression setting only when it doesn't have the platform specific setting. So and the advantage is pretty much even the quality is awful, but advantage is like as you can see, for the 1K texture, it saves 1.1 megabyte per texture, and 2K texture, it saves like 4.5 megabyte per texture. So like if you have 10 light maps, it's a lot. So even like if you don't like the Crunch DXT1, the 1K texture, instead of changing compressed to DXT5, just you can bake just double the size and then bake. It's still half of the size. So just 2K Crunch DXT is much smaller than compressed DXT5 1K. So
that's a big difference. Especially when multiplied across potentially, you know, I don't know what's our maximum textures we support, but say like, you know, 10 to, I don't know, what, 50 or so, I don't even know. But yeah, that multiplies really, really quickly.
Yeah, cool. And yeah, so we created this document, right? So so I know this could be very kind of some it cause kind of confusing because it changed the setting anyway. So it could cause some confusion for our creators. So I put some informations that can be caused by this utility as much as possible. So like possible issues like light map results unsatisfactory or some particle changes or appearing terrain. So I put these. Also, I put some solutions here. So maybe you can refer some these things if you have any problems. Yeah, but I believe this kind of tool can make our creator spaces much smoother on different random even low end devices. So yeah.
I'll put that link in the chat as well.
Cool. Awesome. Yeah, thank you for understanding our creators.
No, Wonkee, you've been working hard. You've been at Spatial almost 2 years, I think now, and working hard at making sure that, I mean, not just things look good, but they perform well as well. So sometimes we got to move fast. Sometimes things break when we move fast, but we move fast and we get things working at the same time. So
cool.
Cool. Good.
Thanks.
Yeah.
Right, and I put some very simple performance checklists. Like I think the most so if your room has app crashes on mobile or some Quest devices, usually it's kind of some memory issue. So you will need to check your assets. But I think it should be okay with the utilities because it prevents it. But it still happens, then it will be worth to check your assets. So if there's any large texture files or large audio files, so yeah, it'll be better to check your assets. And if the performance is bad on in your space, then in most of the case, it's kind of some local issue. So sometimes there are some kind of hundreds of objects that have same materials. Like if there are some street lights, then the same bulbs, there are 100 same bulbs in the space. Even SRP batcher, the Unity batches those objects and draw at once, but still Unity does kind of some curling process. So on CPU, Unity need to calculate its position and determine which object to batch and which object to curl. So it's still, having many objects is still not recommendable. So I would recommend to merge objects as much as possible in your model files. Yeah, also, or maybe you can use static batching, but just merging objects would be the best. But static batching also might help. And there are two different cases for GPU side, but I think it doesn't happen much because most of the performance impact from the memory and CPU. But if you don't have many textures and many objects, but still the performance is bad, then it'll be better to check all the objects. So it's the vertex side and pixel size. So you maybe if you have kind of some downloaded objects or some 3D scanned objects, it'll be worth to check all the meshes. So sometimes I remember there's kind of some necklace on the fashion item which has maybe 2 million vertices in the necklace. So so it could happen. So yeah, if you download your model from the web and random places, then it could happen. So yeah, it'll be worth to check all the meshes vertices.
Yeah, small things can have a huge impact.
Yeah. And if you're designing a very large scene, then maybe using LOD might help a lot because it uses different level of detail mesh of your object. So yeah, also LOD is good. And for pixels, I saw some case that have a lot of transparent objects in the space, which means so to render the transparent object, what Unity does is it renders the surface over and over and over. So which means, so for 1 pixel of your screen, the rendered pixel count could be more than like 10, 12 of the pixel. It can be rendered only for single pixel if it's a transparent object. So especially if the model is double-sided object, which means it models and with double-sided setting and with the two, like for glass, with 2 surfaces on it, then it renders 4 pixels to render the pixel surface. So yeah, this could happen. So it'll be better to check reduce the transparent object. And if there's any double-sided object, then yeah, just disable it to have a better performance. And post-processing should be okay, but depth of field, maybe you can disable the depth of field if your performance is still bad without these issues. Yeah.
Exactly. As Stellar Extinction said, depth of field equals bad. So.
Yeah, true. Yeah. Right. I think. Yeah. So yeah, I would recommend these 2 tools. Yeah. So I usually use Frame Debugger when I to make environments, and I usually also it'll be worth to check the profiler. So profiler is to check the memory, so which is for app crash. So if your room crashes, then it'll be better to check all the assets. But memory profiler would be a great tool to check all the memories in your scene. So for example, if I open where's my memory profiler? Oh, I removed it. All right.
It's a separate package that you have to add to Unity.
Yeah, I just separate package. Maybe yeah, I can show you how you install it. So yeah, if you just copy this name and in the package manager, and here you can add package by name and just paste the name here, and then it will be added in your project. So yeah, I would say this is pretty nice tool to have to review all the resources in your scene. So like I have to install this and open this, and I'm going to capture the snapshot of the current scene. Then you can see all the reviews, all the memory usage, and in the tree map, it shows that how many texture memory I use and some shader or some render texture. So you cannot control the render textures. Actually, these are because it's in the Unity editor, so you don't need to care about these things. And but in the texture 2D, like as you can see, my light maps takes 10 megabytes. This might be not great. I don't know why it's coming. I think, sorry, the number is different here. Anyways, but yeah, if there's, it still helps. So if there's any crazy big large textures, you can see the textures here. So yeah, it's very good to check. And also I saw the audio files can be very large, so it's good to check the audio files and also mesh files. So yeah, this is good tool. And another thing I wanted to recommend is Frame Debugger. So if I capture this shot, and you'll be able to see how many draw calls my scene is rendered. So yeah, keep it low as much possible is good. So yeah, so you can see what's happening in your project when you render this single shot. So maybe if it's Agora, maybe if I capture the frame, this is very low because it's only 16. So also for the opaque object, it's only 9 objects are rendered. So even if these trees are single object, so draw code is very low. So it'll be good to review your scene and which causes very high batch number of your scene, and you can merge them, or you can just reduce or find any other ways to reduce the color number. Then, because this number also can be affected to the shadow map. So when you draw shadows, then the Unity will render all the objects again for the shadow to draw the shadow maps, to draw shadows. And also maybe it's still work in progress, but if we add planar reflection, then planar reflection will be also kind of some renders all the object once more. So yeah, keeping it the number low as much as possible is pretty
awesome. Those are things I didn't know about, so that was like new for me too.
I think a lot of people
will
make use out of that.
Yeah, I've been doing it like probably like the really slow and bad way, where I would just like open up like the project in File Explorer and try and find like the largest files, and then this is like my hacky way of optimizing things. If I find like a large texture, maybe it's like 100 megabytes, I just open it up in Preview and I just reduce the dimensions of it in like Mac Preview until it's like really small. and then save it. So it's like a really long way of like trying to find these things. So like Profiler is like a great way to like at a glance just see. And then I don't know how I didn't know that did exist. But it's awesome that that's there.
These two these useful, correct. All right, maybe it might sound, but anyway, so if I like kind of some like I would recommend to find some, begin with the good reference image to guide your design. And like sometimes I saw that the main light is pretty weak, like there are many random lights in your scene. So I think some having the main light as a main light as the most prominent source is keep the look great. And also sometimes ambient light is too bright for the dark area, or sometimes too dark for the bright area. So handle ambient would help a lot, I think. And like overexposure can happen, usually happens. So like it's like as you can see here, overexposure always look bad. So I would recommend not have any white on your screen. So white is just, which means this means you loses all the details on your surface. So just maybe you can use tone mapping, or you can adjust your light intensity to have a good looking mid-tone details in your scene. Will be much better. Like for this, I would say this guy's too overexposed, so it'll be better to have more some subtle gradient here. But anyway, it was a quick demo, so so handle ambient overexposure. And like sometimes the everything look pretty flat in the shadow area. Like for example, if I not bake, but if I remove bake data and like for example, like in the dark area, like with inside of the shadows, sometimes you can lose a lot of details inside of it. So I think it'll be sometimes it can happen, like when you have somebody subtle ambient source, or like everything's covered by the shadows, then it could happen. So in the case, it's to find a good way to find all the details inside of the shadow. So
Nice. Yeah. You can see. I think it's a good like before and after. Like this is like the before,
Yeah.
or it's just it's kind of just very dull, and then the
Yeah.
after just it's like on an entirely different space. It's insane.
Yeah.
Yeah.
Yeah. Actually, this also happened a lot when we are using the GLTF custom environment. So yeah. Yeah, it's much better now with the Unity, the powered creator toolkit. But yeah, anyway, it could still happen. But yeah.
Yeah.
Oh yeah. Oh my god. Yeah. I should have mentioned this. Like so. I increased the main light intensity here, right? But oh my god. Oh, I already increased this. So all right. So this was the original. Sorry, the order is a little bit mixed, but yeah. This was the original brightness of the sky, but as I increased the main light intensity, so as you can see, sky is weirdly darker than the main light, right? So which causes the sky looks like kind of some movie set, the matte painted the sky, right? This is weird. Yeah. So sky should be always brighter than the main scene. So you need to keep the sky. Yeah, sometimes it sometimes happens. So if your sky dark, then you can increase the brightness by increasing the exposure in the sky.
It's a good little detail.
Yeah. But yeah, I like sky because so I like very bright sky.
Yeah, that's awesome.
Nice.
For the bright sky, what I did is like so I wanted to make the sky look shiny. So I added this one. So it's kind of some emission object, like 200 the brightness of it. So it causes a bloom of the sky, sun. So this kind of trick can make your scene much much bright, more light. Yeah, in your.
That's cool, and it's cool how when you like start to go behind the edge of the wall, it like the bloom changes.
Yeah. So this kind of tricks, but I think that having good level brightness of sky is always very making your scene much better. So
totally.
And post-processing effects. So sometimes if you started put your to adjust the scene, like if you want to more contrast, then maybe you can just simply add contrast using this kind of some post-processing. But if you started using more processing, then the result will be pretty different with your original light settings. So like for example, if you add contrast here, then it will be very hard to change your light. So I would recommend to not using post-processing to adjust your color. So just starting from the ambient color and adding light very carefully, and then use post-processing at the very final touch. So
wait till everything else is done, then make it the very, very, very last thing. A little bit of post-processing. Okay.
Right. Yeah. Like for example, like we don't support post-processing for Quest. So for this scene, even it uses only bloom. So this just there's no difference with or without post-processing. So I try to.
Okay, so you don't necessarily need post-processing every time, but it's just there if you want to. Okay.
Yeah. Yeah, great.
Nice.
Sure.
Very nice.
I think that's pretty much everything, right? Yeah, thanks so much.
No, thank you, Wonkee. We all need to be thanking you forever from now on.
Standing ovation.
Yes, yes, thank you.
Round of applause.
Thank you for the long time. Yeah, I should separate this, but yeah, thank you for.
No,
this.
it's all good. We got it in at once. We can separate it, and this is all being recorded, so this will go up on our YouTube and channels and things like that. We may even break it down into little bite-sized chunks because there was so much, like, in terms of like how to do this, how to do that, like all these little things that we'll break it down and put it out there. But yeah, thank you, Wonkee. That was exactly. I mean, people are saying it. They called it a master class. They called you a god. I'm quoting like that.
Yeah,
there's a lot of good stuff in there. So thank you, Wonkee.
Thank you.
Hopefully now we'll see. Yeah, legendary. You're being called in the chat. Hopefully now we'll start to see, or not now, we'll continue to see, and now people will start to be able to, creators will be able to really level up the visual quality of their spaces and do it in a way that I think maintains performance and like the efficiency and stuff like that too, which is really, really key.
Huge.
So yeah, definitely. So that was a 2-hour masterclass in learning. That'll go in the history books. So
yes,
that was awesome.
Nice.
But yeah, thank you, Wonkee, and I think that'll be a wrap for this week's Teaching the Toolkit.
Cool.
Yeah, that's awesome. So we'll see everybody out there again. We'll see you guys later this week for Surf and Spatial with Hawa and Jack and the rest of the team, and then back next week. Tuesday at 2:00. The topic is going to be around testing your games. What's good processes for going through once you've built your game and you want to make sure you do go through appropriate ways and methods for testing. Tara from our team is going to be on and talk about how we do like quality assurance and testing in our games. So we'll see you guys next week. Thanks again, Wonkee and Jack.
Awesome.
And everybody else out there that joined and watched.
Have a good day.
Peace out, y'all.
Peace. Bye.